So now we're going to look at the graph of one of the reciprocal trig functions, sec x. So I'm trying to sketch the graph of 3 sec x plus 2. I'm going to do this in stages. I'm thinking firstly of sec x. What is sec x? Well, sec x is 1 over cos x. So I'm going to start by drawing the graph of cos x. But I'm going to only draw the graph from 0 to 2 pi because that's the interval that we're interested in. So this is what cos x looks like, and clearly we're in radians here, with the maximum values 1 here, and the minimum value of -1 here. So when I try to draw sec x, it's 1 over cos x. So when cos x is 1, which is here and here, sec x will also be 1. So I know the graph goes through here and here. The graph of sec x goes through those 2 points. And when cos x is -1 here, sec x is 1 over -1, which is -1. So we know the graph of sec x goes through there as well. Also, when cos x is 0, which is here and here, sec x will be undefined because we're dividing by 0. So we'll have vertical asymptotes here, indicating the discontinuities in the graph, the values of x for which sec x is undefined. So putting those facts together, those are the asymptotes to start with, and then remembering that the graph of sec x goes through these 3 points, I can then look at the values of as cos x gets smaller and smaller, sec x will get bigger and bigger, and when cos x gets smaller and smaller here but negative, sec x will get bigger and bigger but negative. And when we complete the graph, that's what the graph of sec x looks like from 0 to 2 pi. Okay, so that's my starting point. I'm still trying to draw the graph of 3 sec x plus 2. So what I'm doing, I can think of this as 2 transformations. The first transformation is multiplying by 3, and then the second is adding 2. So when I look at this point here, of the value of y as being multiplied by 3, so that would take it up to 3, but then we're adding 2, so this value of y would become 5, and so would this value of y become 5. The value of y here is -1. 3 times -1 is -3, but then when we add 2, we go back to -1 again. So the graph of 3 sec x plus 2 looks like this. We've stretched it by a scale factor of 3, and then we've translated it by 2 units in the positive y direction. So that's the graph of 3 sec x plus 2. The blue graph is the one that the question asks for. The second part is asking us to find the set of values of k for which this equation has no solutions. So we're trying to find where our graph here, the graph that we've drawn is y equals 3 sec x plus 2. We're trying to find where the values that we don't get values of y for. And when we have values, when we look at the graph, the top part of the graph, then y can have values of 5 and above. It can have values of -1 and below. These are all values of y here, which are -1 and below. These are all values of y which are 5 and above. So the values of k or the values of y which are not coming out of the graph of 3 sec x plus 2 are the values of y in between. So anything less than 5 and bigger than -1, those are the values of k that we don't get out from our 3 sec x plus 2. So therefore the answer to the question is k is between -1 and 5, not equal to -1 and not equal to 5. Okay, a little bit of a tricky thought process there, but hopefully you understood what I was trying to say.